Hope my screen is visible. Can anyone confirm if my screen is visible? Okay. Okay. So we have completed the Java fundamentals. So Java fundamentals has been completed. So now we are going to look into the actual topic, which is called as object oriented programming system. Oh yes, oops. Right. So before even discussing about the oops, we will understand something about programming paradigm. Programming paradigm. Programming paradigm. So what is a programming paradigm? That is the question. What is a programming paradigm? Okay, programming paradigm. Let me give you a small theory on this. Okay, we can say that the programming paradigm means a style or standard way of approaching a problem or standard way of writing a program. So what does it mean is the programming paradigm is a standard way of preparing a program, or I can also call it it's a style of writing a program. It's not necessarily the Java program. It is a style of writing any computer program. It is a style of writing any computer program. It's a style of writing any computer program. So we call it as a programming paradigm. Right? For example, if I want to compare this with a real-time analogy, I can say that. So when I ask you to prepare, when I ask you all to prepare veg biryani, when I ask you all to prepare veg biryani individually, so there are this many people in my in the lobby, the team's lobby. You see, there are this many members in the team's lobby. If I ask you individually to prepare veg biryani, okay, each and every of you are going to follow a different approach, right? Each of you are going to adopt an approach, right? The approach that is following by Chaitanya is not going to be the same the approach is following by Darshini, or the the approach that is following by Darshini is not going to be same the approach that is going to be followed by Jyoti. It varies from person to person, right? I can say that Jyoti is going to have her own style, and Darshini is going to have her own style of preparing veg biryani, and Chaitanya, and so on, right? So likewise, programming paradigm, I can say that programming paradigm is a technique. Programming paradigm is what? Programming paradigm is a technique to write a program. Right? So this is a typical instruction about the programming paradigm. So best example is, this is a real-time example. So if I ever ask you to prepare veg biryani, each one are going to follow a different object. Likewise, if I ever ask you to solve a problem, for example, there is a problem here. There is a problem here, right? If I give you a problem, it can be any kind of problem. Let us take that a mathematical problem, right? So each one of you are going to provide me a different solution, right? I can have n number of solutions for one problem. It is not necessarily that the problem A is going to be have the unique solution. It can have n number of solutions, yes or no? Mathematically, for example, to perform any complex operation, any complex mathematical operation, that operation no need to be follow the same sequence of procedures. It can be approached by many number of ways. Some people they use calculator, some people they use pen and paper, right? Things like that. Making sense? Everyone has their own approach to solve a mathematical problem, right? The answer is going to be same, but the approach is going to be different. Approach is going to be different. Raji is going to give approach, solve the problem with approach 1, right? And Samyukta is going to solve the problem with approach 2, right? Likewise, the approach varies from person to person for a specific problem to be solved, right? So this is how you can imagine the concept of programming paradigm. So if you consider computer programming languages, each and every programming languages, let us say Java, for a typical problem, Java is going to follow an approach. That approach is called what? OOPS. That approach is called what? OOPS. Java has adopted an approach to solve any kind of any kind of problem by adopting the concept of OOPS. OOPS is one of the programming paradigms. We will discuss about that. So this is the simple understanding. This is a foundation level understanding. So making sense so far? Everyone type something in the chat box. Yes, no, maybe. Right, so far so good, right? Okay. The next question is, why it is necessary to have a programming paradigm? What is the necessity behind this? What is the necessity behind the programming paradigm? That is the question, right? So it is like Java is not the only language in the computer industry. There are so many languages. There are more than 1,000 programming languages that is available in the computer market, and each and every languages are being used to perform a certain kind of to develop certain kind of web applications, mobile applications. So it is just like talking to a computer. Programming language is just like you design a programming language, and this programming language will help you to talk to a computer. Java is one of the languages in the computer world, right? So each and every language like Java, C, C++, Python, we have many number of languages, but these are the prominent languages that everyone knows. C++, Ruby, JavaScript, Java, Python, right? These are the programming languages that we have in the market, right? For any given problem, C is going to follow an approach to solve that. C++ is going to follow an approach. Ruby is going to follow an approach. JavaScript is going to follow an approach. Java has its own approach. Python has its own approach. It is an internal design. Right? So we can conclude that the program can be, or I can say that the code can be written by anyone that the computer can understand. You can also develop your own program to ensure that the computer is understanding. But the good programs, I can say that the good programmers develop a code that the humans understand, right? For example, if you take Java is a high level programming language, right? It is understood by computers. It is designed to be understood by the computers, as well as it is also designed to be understood by humans, right? Just by looking at this code, you are getting something, right? It is very readable, right? Don't you think so? Very readable, right? So this is giving you some justification, yes or no? This sentence is giving you some justification, right? The code can be written by anyone that computer can understand. So in this case, code you can also assume it as a language. The language can be written by anyone, or language can be developed by anyone that computer can understand. But the good programmers develop a code or language that the humans can understand. Right? Java is typically one of the programs. It is well understood by the computers as well as human beings. Right? And by if any chance, if there is no programming paradigm, if there is no concept of programming paradigm, what happens? For example, the same veg biryani, right? Take the same veg biryani, right? So there are many approaches, or there are many procedures, that one can follow to prepare veg biryani, right? Ideally, in order to cook any food, it is necessary that we need to have what? We need to have a flame. Flame in the sense, fire is mandatory, and raw materials are mandatory. These are the integrants that is very much essential, right? Raw materials, water is mandatory, rice is mandatory. Rice is also the part of raw materials, so let me remove that. Flame or fire and raw materials, these are the mandatory things, right? By using these things, and tools like utensils, knife, whatever it is that is required to cut vegetables, right? So these are the three things that is mandatory, right? But how these three things are necessarily being used by each and every person, that's the question, right? If you do not have fire, raw materials and the tools, right? If the procedure is not organized, right, what it creates, right? For example, if veg biryani is being prepared by myself, if I am preparing a veg biryani, I will ensure that all the necessary steps are being written in the form of recipe, right? Because sometimes it becomes very successful. The taste is going to be very good. And if I want to reproduce this for the next time, by looking at the recipe, I can do the reproduction. I can reproduce, right? I can prepare the same kind of biryani without compromising the taste, yes or no? So here the recipe is going to organize the what? It is going to organize the steps or the procedures. There are so many steps involved to prepare veg biryani. Okay, if it is successful and if it is tasting good, right, I will store the steps in the form of recipe. So whenever I want to prepare the same veg biryani next time, I will just look at this recipe and I will just prepare the biryani, yes or no? If there is no recipe, right, today if I prepare biryani, if there is no recipe, if I am not saving the data, right, today it may taste good, tomorrow it may taste bad, right? Tomorrow it may taste bad, and day after tomorrow it may taste worst. We are not sure. The output is not fixed. It changes unless and until I remember each and every steps. Likewise, if there is no concept of programming paradigm in the computer world, okay, it is going to increase the complexity. First point, it's going to increase the complexity. Second point is, if you see the Java program, it is completely readable. The Java program is what? It is completely readable. By looking at it, it's in English. You can say at least, you don't know about the internal things, but you can at least read class, test, opening parenthesis, public, static, void main, something it is readable. Right? If there is no procedure, if there is no internal steps, if there is no order, right? If everything is written in a language that the computer understands, not the human being, that the computer understands. Example, the bytecode, zeros and ones. This is the bytecode. This is the typical bytecode. It is readable by us, but this bytecode is going to return a separate number, or it has a specific code. Computer, which computer can understand, we don't understand that. It's non-readable, right? So what happens if the program is, if the programming paradigm concept, if there is no programming paradigm concept, the readability will be reduced, decreased. This is one of the disadvantages. And the third one, okay, it would be hard to test. It would be hard to test. Fourth one, it would be hard to maintain. Fifth one would be hard to change. These are the actual drawbacks if you're not following any, if any programming language is not following any programming paradigm. Okay, these are the drawbacks that it is going to face. The programming language won't be a successful programming language like Java, C++. If there is any programming language that is not following any order or any rules, these are the issues that the programmer is going to face. If the programmer is going to face some issues, it means the programming language is not going to become successful in the market. Yes or no? These are the things that it is going to face. Same thing. If I give you the recipe, you can just reproduce it, right? You can just make the biryani over and over again with the same taste and with the same style, right? If it is not organized just like that, the programming paradigm is just like what we want, just like an approach of the recipe. Each and every programming language is following a paradigm. We'll discuss about that. If it is not following any paradigm, this is the issues that we are going to face. Right, the last point is it is less structure. Right? Any questions so far before we proceed? So there will be some theory before we jump into the programs, before we understand the actual concepts. So far, are we good so far? Are you with me till now? Everyone, say something in the chat box. Yes, no? Yeah, good. Okay, now we will discuss about. So we got to know what is a programming paradigm. Very simple, right? Very simple English. It is a standard way of preparing a program. And the second thing is it's a technique, right? Why it is necessary to have a programming language? This is why it is necessary, right? Whatever the programming language that is introduced in the market, it should always be a high level programming language where the human beings can understand. If the human beings are not able to understand that, it is not a successful programming language. That's why I said it can be written by anyone. That a program, even you can also write a program that the computer can understand. But if you are capable of writing a program where the humans as well as the computer can understand in the same level, then that is going to be the successful programming language. In order to get that successful programming language, you need to follow what? Programming paradigm, right? If you don't follow programming paradigm, these are the issues that we are going to face. So now we are going to discuss about the types of programming paradigm. Types of programming paradigm. Okay. So it is categorized into two types, guys. Okay. First one is imperative programming. Second one is declarative programming. And again, this imperative programming is again subcategorized into two types. One is procedural oriented programming. And the second one is what? Object oriented programming. Right? So again, the declarative programming is subcategorized into two types. One is functional programming, right? And we have what? Logical programming. Logical programming, right? So now let us understand this. Let me bring this to the next line. Okay, not sorry. Okay, so Java has adopted the concept of what? Java has adopted the concept of examples for object-oriented programming in Java. We have Python, we have C++. Java, Python, C++. Okay, examples of procedural oriented programming. We have C language. You can say C language. And functional programming, we have Haskell or JavaScript, I can say. And again, JavaScript is following two approaches. I mean, it is a multi-paradigm programming language. It follows functional programming approach, as well as object-oriented programming approach. Typically, it is being used for functional programming approach. JavaScript. Okay. The logical programming, we have I think for logical programming we have Haskell, or I can say that we have Haskell. Or Prolong, I can say. Okay, so now tell me one thing, guys. We got to know the exact differentiation, right? So if you see here, if you learn Java, right, Java is following this object-oriented programming approach. If Java is learned, right, then learning Python, C++, and the languages that has adopted object-oriented programming approach is going to be easy. Once you complete Java, these things will not take much time for you, right? You will learn a lot. I mean, the learning of Python and C++ and the remaining languages are going to be easy because it is following Java or an object-oriented programming approach. You see, Java is here. There are many languages, and Java is here. Java is following a programming paradigm, which is what? Object-oriented programming paradigm. We got the place of Java. This is where Java resides. This is what it is following. This is what, Java is to solve any problem. Java is following this approach. We are going to discuss this approach, and again, this approach is categorized into many types. Especially, there are 7 types. After completing those 7 types, it is like we have completed object-oriented programming concept, right? So these are the types. First, we will understand each and every type. What is imperative programming? What is declarative? Before actually understanding this, okay? Imperative programming, right? So imperative program is like, you will just give the instructions to the computer by telling how to perform the task. Or else I can say that imperative programming usually tells the computer how to do the task by giving a set of commands or instructions in a particular order. For example, if you are preparing a veg biryani, right, there has to be an order, right? Order in the sense, first thing is washing the rice or rinsing the rice. Rice should be rinsed, right? Then you have to soak the rice for something like, around 30 minutes, something like that. So you keep it aside. The next step is cutting vegetables, right? Next, after cutting vegetables, you take a pan or you take a bowl or take a cooker, right? You add oil, you add ghee, right? After adding oil ghee, you add the vegetables which was cut, right? You cook those vegetables and you do so many things, right? After that you add the you remove the water from the soaked rice, then you add that in the vegetables that is being cooked. Then you add 2 cups of water depending upon the quantity, right? You lock the cooker and you leave it for 1 whistle in the low flame, right? And biryani is ready. So there is an order, right? From sequential order, you cannot violate this order, right? Same like imperative program is just like that, right? So imperative programming tells the computer or instructs the computer, right, how to do the task by giving the set of instructions. Set of what? Set of instructions or commands, I can say, in a particular order. Making sense? Particular order. Especially, you tell the computer to execute the instructions line by line, right? I can say that you give the or you command the computer. You command the computer to execute the instructions line by line. Line by line. Imperative programming. So when I say imperative programming, so this is the highlighted line. You usually give the commands to the computer. The computer needs to follow what? All the instructions needs to be executed line by line from top to bottom. If you have 10 instructions, if you have 5 instructions, 1 2 3 4 5 instructions needs to be executed from top to bottom, line by line. First this needs to get executed, right? Then followed by this, right? Followed by this 3, then 4, then 5. This is an approach, right? When your computer is following an approach where the instructions are executed from sequentially or line by line, okay, that approach is called as what? Imperative programming, right? For example, so when you want to add 2 numbers or you want to subtract 2 numbers, what is the typical procedure? First you need to declare the numbers, right? First you need to declare the number a equal to 100, int number b equal to 100, right? So declaration is completed. Then you need to provide the functionality. Functionality is like integer c equal to a plus b. So this is the functionality. So these 2 numbers are added, 100 and 100 is getting added, and again this value, the resultant value, is getting assigned to the new variable, right? This is the functionality. So actual addition is happening here, right? After this you need to display what? You need to display the values in the console. See, so this is going to print the results of what? Result of addition of 2 numbers, right? And the next thing is you want to subtract. Again c equal to a minus b, right? C equal to, so what we are doing, we are just reassigning a value, reassigning a resultant value to c. What value we are reassigning this time? A minus b. 100 minus 100, 0. Here it is going to give 200, here it is going to give 0. We are using the same variable, reassigning, and here we are changing the functionality. Previously it was a plus b, now it is a minus b. Okay, this is going to give the subtraction of 2 numbers, right? You see this when the let me take this, right? This is just the algorithm, just not the don't find any syntactical mistakes here. This is just an algorithm. Okay, if you consider this, okay, the when your computer follows an approach to solve the problem from like sequentially, line by line instructions. When the line by line instructions are getting executed, this is the first line. After executing this, second line. After this, third line, fourth line, fifth line, sixth line. Then done. Execution is done. Right? Because of the sequential execution, because of this line by line order execution. Okay. This kind of approach, the approach that we are, that the program is adopting, this approach, line by line approach, is called what? Imperative programming. Making sense? Making sense, everyone? Right? It is not like this thread clearly knows that when you design a problem on top of imperative programming, it is like you're giving instructions to this thread. You are feeding this thread. You are telling this thread to execute the instructions. What instructions? All the instructions, line by line. Right? You are feeding this thread with an information saying that execute all the instructions or all the statements line by line order. Right? So that kind of approach is called what we call as imperative program. Making sense? Just type something in the chat box. Everyone, are we good so far? Are you with me now till now? Line by line. So a lot of theory will be there. Okay, we need to focus on theory because this will make a lot of sense when we start understanding the OOPS concepts. Yeah, good. Okay, this is making some sense. Okay, so we have completed what? Imperative program. We have just understood what is imperative program. Okay, so next let us understand what is the procedural programming and why the C language is designed, or why the C language has adopted the concept of procedural oriented programming. What does it really mean? Okay. People used to say, everyone, not only people who wants to learn Java or Python. Okay, they usually ask me, can I learn Java, Python directly? Right? Now you tell me, Java and Python, they are part of object-oriented programming language, right? People ask me, can I just learn C language and come before learning Java? People used to ask me before taking Java class. They ask me, can I just learn C languages and come so that I can understand Java easily? It is not like that. This is a different approach, right? It's a completely different, no? Right? Even though there will be an added advantage, so what I recommend is, there is no prerequisite to learn Java or Python or C++. If you learn Java, this becomes very easy. Python is nothing when compared to Java. Interactively, right? These languages are adopted. They have adopted the object-oriented programming, right? So it is not required to learn any other language before learning this. Right? So let us jump into the next topic. Which is one? Procedural oriented program. Procedural oriented programming. Let me remove this. We know that it is C. Okay. So usually the same example, let me take veg biryani. Right? So I was saying you that there is a set of instructions that you have to follow to make the veg biryani, right? So what if I can split this job? It is not necessary that only Balaji can prepare veg biryani by himself, right? I can say, what I can say, I'm living in a room. I can say that let me clean the rice, or let me rinse the rice, right? This is my job. Rinsing the rice and soaking the rice and ensuring that the rice is getting soaked for at least 20 minutes is my job, right? So the second job, I can order one of my roommates to take the second job, which is what? Cutting vegetables. Right? I'm taking this job. I am ordering one of my roommates to take this job, cutting vegetables. And I'm ordering 1 hour, when we are ordering 1 hour other person, to cook the vegetables. Right? So we are splitting the task into several. Actual task is being splitted into several subtasks. And this is an actual task. This actual task is being splitted into several subtasks. Okay, this approach is what the procedural programming approach. Same thing, the same thing. Okay, instead of executing this in the linear fashion, okay, you divide the task. So how do we do that, sir? We'll understand. Okay, let me put it down. Okay, in procedural programming, the major problem or major problem, I can say that major problem or the program will be divided or split into several subproblems or programs. Major problem is getting divided into several subproblems, right? So it means we usually decompose the major problem, one problem, singular, into several subproblems. Several subproblems. Okay, this is what the procedural programming approach is. Right. So I can add few more points for the better understanding here. The first point. What is a procedure actually? What is a procedure? When I say procedure, see, even for the same vegetable biryani, this is a procedure, right? This is procedure one. This is another procedure. This is another procedure. Each and every procedure has its own independency. Okay, there is no direct relation. It is not like, you know, this all the things needs to be done at the same time. This can be done independently. I can say procedure 1. This can also be done independently, procedure 2. This can be done independently, procedure 3. I am splitting one procedure, one big procedure into small procedures. Making sense? By this I can say that a procedure is what? A procedure is a section of code that performs a specific task. Right? This is one task, section of code, one task, section of another code. It is not actually a code, it is actually a procedure. I can say that section of procedure, I can name it as task 1. Section of procedure, name it as task 2. Section of procedure, task 3, and it keeps going, right? Until the all the procedures are successfully completed, right? Same thing, right? It is also referred to as top-to-down approach of problem solving. The third point is one should always treat the data and the logic as separate entities. I will explain this. This will make more sense now. For example, when I can have any kind of data. In this case, I am taking a data like 100 is a data. 100 is a data. I am storing this data to a variable here, right? And I have another data. 200 is a data. I am storing this variable, or I am assigning this. Sorry, I am assigning this data to the variable b. So I can say that I have two data: a equal to 10, a equal to 100, and b equal to 200. These are the datas, right? And when I say a plus b, this is the logic. Data, this part is talking about the data, the part that is before the and word. This is part talking about the data. This part is talking about what? The logic, right? So when you separate the data and logic into, or when you when you keep the data and logic, or when you assume the data as logic into two separate entities, right? So that kind of concept is called as procedure oriented programming approach. How do we approach that? We will discuss now. Okay. So previously it is not like that. So everything is placed in the same entity. I mean, in the same part, same body. Data is involved in the same body, and the function and the logic is also written in the same body, same space. Now we are going to separate this. To achieve what? When you separate this, it is like achieving procedural oriented programming. It is like adopting the concept of procedural oriented programming. How do we do that? I am going to explain this to you now. Okay. Pay some attention here, guys. Pay some attention here. Sorry about it. When I say int a equal to 100, int b equal to, and again 100, right? So this is the data, right? So I am separating the data and I am adding a functionality or a logic. What is the logic? This is the function I am adding. Add two numbers, a comma b. Second, subtract two numbers, a comma b, right? And again I have another methods, void add two numbers, integer a comma. I will explain you about this program, no worries. Okay. Now subtract two numbers, integer a comma b. Over here I am writing system dot out dot println a plus b a minus b. What was my explanation? I said you treat the data and logic as separate entity. So this is the data, right? So to achieve the logic, to perform addition, I am writing a function for addition, and I'm writing a function for subtraction. I have separated the data and the function. These are talking about the functionalities. Over here, if you see, I have two datas, okay, and these two datas are getting manipulated as a data and being assigned to the third variable. In this case, I'm using a function here. We'll discuss about this function in the future. For now, just understand that this is a separate entity and this is a separate entity. Okay, so let me take the main screen for the better understanding. Focus here. Okay. Now, if you observe this is the data, and this is the logic. So how this approach is going to work? Firstly, right? So we usually, it is a top to bottom approach, but there is a difference. Okay, first integer a equal to 100 will get executed. So value 100 will be stored to the variable a. Second line, c equal to 100, it means value 100 will get stored to the variable b again. Okay, and now here if you see, right, we are calling a function. What is that function? Add two numbers a comma b. There is a function in the same program. The name of the function is what? Add two numbers, and it is accepting two values a comma b. Okay, now this thread is clever enough to identify this function. This thread is clever enough to identify this. So this function is identified here. You see, this is what the function is, right? Add two numbers, matches add two numbers. It is accepting what? A comma B, which are integers, right? So here it will consume two values, which is A comma B. The value of A is what? 100. Not like this. Okay. Here it is accepting two values. A is 100 and also B is 100. Okay. Now the main thread will look for a function which is accepting two integers, 100 comma 100. Like add two numbers, identified. Add two numbers is identified. Accepting what? A comma B. A comma B is what again? A is equal to 100, B equal to 100. Right? 100, 100. 100 is of integer type. This 100 is also of integer type. Identified. Right? So the control will be transferred here. It is skipping now. It is skipping the fourth line. From here it is jumping here. It is a function call. Right? Here the actual logic is there. Logic is written here. Logic is written separately. Hope it is making sense. Logic is also the part of the program, but it's again the part of the program. It is mentioned separately in a subprogram. So it comes here, it will execute this. This will execute this body function. What is the first line? Says system A plus B. Okay, A plus B is what again? 100 plus 100. 100 plus 100 is what? 200 will be displayed in the console. Yes or no? After displaying this, it will go back to the place. It will go back to the same place, and the cursor will be moved to the next line. Right? Next line is what? Subtract two numbers. It means it's also a function call. So this is it will identify. Subtract two numbers. What numbers? This is the function name. It is accepting two parameters A comma B, which is what? 100, 100 again. 100, right, comma 100. So this thread will identify the function name, which is add subtract two numbers, which is accepting two integers, 100 comma 100. This is where it is identified. The control will be transferred to the same function. Thus it is accepting 100 plus 100. Logic. Here the actual logic is written for subtraction. Previously the logic was for addition, this is for subtraction. Okay. After performing the action, the output 0 will be displayed in the console. Right? Output is 0 will be displayed in the console. It will go back here. Right? So you see, I have marked these things in blue color. It's blue square, blue whatever it is. Right? So red color, these are executed. The color in red are executed. So it won't touch here. From here, the control comes here. So there are no instructions to be executed. Program will get terminated. Execution will be completed. For understanding this, there is a lot of difference between this previous problem. Data and the logic is written in the same sequential order, but here it is also following top to bottom approach, but again you are treating data as a separate entity. Don't you think so? The data is being treated as a separate entity, and the functions are the logic is being treated as a separate entity. Both are being treated differently. Making sense? This kind of approach is what? Procedural oriented programming approach. Example, C language. C language is following this approach. Sir, why we are discussing about C language? We are learning Java. Why this is necessary? This is a prerequisite, small prerequisite. Making sense, everyone? I can say that. Point to be noted. Please be informed that the difference between the functions is it would always the difference between the functions and for loops. So for loops, we have already discussed about the for loop. For loop is not only for Java. For loop is for all the programming languages. You will see the for loop in C, C++, Python, everywhere you will see. right? For loop actually do not return any value. What does it mean? We will discuss that. But for now, just understand that functions are going to return something. For example, if you go to a shop, you want to purchase a kg of rice. Okay, there is an exchange, right? You do what? You give the money. You give the money to the shopkeeper, right? He is going to return you something. What is that returning thing? The rice itself, right? You give something, and for that something, you will get something. Give and take policy. I mean, something will be returned to you. That is not the case with the for loops, right? To imagine this, we need to complete object oriented features. Okay, for now, just understand that. Please remember the difference between functions and for loop is for loops are functions return something. For loop does not return anything, it will just perform the action. You give something, it performs a job, but it will not return anything. But you can see what job is being performed. But functions are like you give something, for that something will get something, even get. For loops are not like that. You give something, for that thing some action will be performed, some kind of action will be performed. Okay, this will make more sense, not now, in the future classes. Okay, but for loop does not return anything, right? So we have completed examples. Example is C language. If you see one thing, right, this is procedural oriented programming. This is subtopic of imperative programming. Okay, so imperative, even this imperative program is also following top to bottom approach. It's also following top to bottom approach only. Top to bottom approach only. This is also following. Okay, the execution starts from top, from here, top to bottom approach. But the difference here is, here the logic and the data is treated as a same entity. Both are recognized as the same entity, but here the logic is being treated as a different entity, and the data, I mean, the logic is will be treated as a different entity, and the data is also will be treated as a different entity. For logical calculations, you take a function or method. To save data, you take variables. Here you see, for the function also, to perform any logical operation, you are using the variable itself. Yes or no? Making sense? Everyone, are we good so far? Any confusion? Everyone respond. Chaitanya, Jyoti, Darshini, everyone, Sweta, Samyukta. Are we good till now? Right? Good. Okay. So now, object-oriented programming. This is very interesting. Okay, actual topic. Our Java topic. Java has adopted this. Okay, because of this adaptation, or because of this adoption, Java has become popular. Now we will get to know why Java has become popular. Okay. Java is following an approach. What approach? Object-oriented programming approach to solve problems. Okay, what are the advantages? You will get to know now. Object-oriented programming. So this approach says an entire program. I mean, when you want to develop a program, you develop program by using classes and objects, right? Whenever, so if you get, what we call it as, we almost exhausted our free time, 1 hour of time. Okay, if you get logged out or kicked out of the lobby, try to rejoin it. Okay, don't assume that the classes are over. Everyone rejoin. Okay, whenever you want to build a program, whenever you want to build a program by using OOPS approach, or I can say that whenever you want to build a program just by using classes and objects, this kind of programming approach is called what? Object oriented programming approach. Very simple, no? When someone is asking you, okay, if you are asked to explain what is object oriented programming approach, this line would be enough. When you want to build a program just by using class and object, this kind of programming approach is what? Object oriented programming approach. Okay, theoretically it is okay. Okay, theoretically it is readable, but is it understandable? It is not understandable because there is a class. When I say class, we always assume that the classroom classes, right? The classes that you are actually going into everyday college classes. So we always bring that, we always compare this word. Our imagination will go there, right? But classes means a separate thing. I mean, it has a separate meaning for Java, right? So I cannot say Java classes. When I say Java classes, it means, right, you are learning something from this Java classes. But when I say again for the Java classes, there is a different meaning in Java program. Don't you think so? The Java classes, right? It depends. This meaning depends upon the context, right? Where I am using this. When I say please join Java classes, it means you are learning something. You are learning Java. When I also say these are the Java classes, it means this is something a part of Java, part of the programming language. So from now, when I say classes, right, this is something. It is a vocabulary that is reserved for Java. In Java, there is a different meaning for this. And objects, same thing goes for objects. Right? In real world, there are many objects, but in Java, when I say objects, it means it is a memory allocation. Memory allocation. Making sense, everyone? Right? It will make more sense, right? So I can say that the entire program will run based on object instructions. Okay, so let's continue this. So Sambodh theory says objects are always equal to what? Real-time entities. I can say class is a blueprint. Class is a blueprint on which objects are created. Right? The class usually has properties and behaviors. The objects are going to be created when this class are instantiated. So it is not making any sense for you. I understand that. Okay, so we'll give you the justification for all these 3 lines. No worries. Okay, so it is completely readable, I guess. Class is a blueprint. Okay, when I say class is a blueprint on which objects are created, okay, so what I really mean is, okay, class is a blueprint on which objects are created. What does it really mean? What is a class? Okay, Java class is something different, and just now I have mentioned it, right? So when I say this, I also say that Let me take an example here. For example, if I want to construct a house, I think people who have joined these classes from the beginning, they know this already. If I want to construct a house, so constructing a house is going to have many phases. We need to ideally we need to follow many approaches, right? So there are two common approaches, right? One is what? First approach is, approach is different to two types. Not approach. Whenever a house needs to be get constructed, we need to do what? Planning, and we need to do what? Execution. What is a planning again, right? What does this planning mean, right? So we need site clearance, we need, right? We need an architecture who plans the house, right? We need the budget estimation. There are four things that we need to consider, right, to construct a house. One is what? Building plan, right? So you just invite an architect or an engineer, okay? You tell him the requirements, okay? Based upon your requirements, right? Based upon your budget, right? Based upon the size of the land, based upon the size of the land, right? And based upon what? Based upon the documentation. This planning can be completed, right? These things are required to do the planning by the engineer, right? Do you think that without all this you get the perfect plan to construct a house? No, he will ask you, the engineer is going to ask you, right? Documentation, right? And again, execution phase. After once you plan, okay, it is not like once you just plan the house, plan constructing a house, like the house will be produced just like that, right? There is a lot of processes involved for the execution, right? You need to build the strong foundation, okay? You need to hire what? You need to hire employees, right? So you need to hire what? You need to hire plumbers, right? You need to do what? You need to hire electricians, labors. Lot of things are involved. This execution phase. Okay, so this planning phase is what we call it as this. If you want to convert this analogy to the Java language, we call it as classes, or I can say class. Okay, this execution phase we call what? Object creation. Okay, so typically class is always talking about the plan, okay, and object is always talking about the execution of the plan, executing that plan, right? That's why, okay, when I take a class, for example, a simple class I am taking, class test, okay. So it's a class test, okay, just a opening parenthesis and a closing parenthesis. Nothing is there inside. Okay. In a class, typically I should have what? I can have two things. One is properties. Properties are also called as data. Second one is what? Behaviors. Behaviors is also called as what? Logic, business logic. It's a plan. When you in the real world entity, when you are building a house, okay, you need to have a set of data, right? This is a data, the budget is a data, acquiring land is a data, documentation is data. So many things are involved. After assuming all these things, the engineer is going to do what? Is going to design a perfect plan for you. Likewise, when you're writing a program in Java, okay, the program needs to be written in a class test. Okay, in this class you can have a data, you can have a behavior, you can have data and you can have a behavior. For example, okay, let us say that my data is simply integer a equal to 100 and integer b equal to 200. This is talking about the data, right? And behavior, when I talk about behavior, you will what we call it as, you will adopt a kind of method or function. I can say that void add system dot out dot println a plus b. This is talking about the behavior. Why this is talking about the behavior? Okay, you are using this function to manipulate this data. This is data, this is the behavior. So this function is going to add these two data, using this two data and giving something in the console. Okay, what kind of thing is that? Addition of these two numbers. Typically, can I say that this is just a blueprint? By looking at this, okay, I can say that this is the class which is also called as a blueprint. It is just like when you for example, when you are constructing a house, the planning phase, the engineer comes, the engineer is going to give you the plan. He says that this is your land, sir, and inside this land, and we can build an house. So inside this house, we can bifurcate this house into hall, a big hall, and a bedroom and a kitchen. Right, this is the entrance. Right, the plan is present in the form of paper. On top of the paper, you can see the plan. It doesn't mean that once you see the plan, the building gets constructed automatically. It's just an idea. Likewise, this is going to consume any memory, the paper, right? When the plan is produced, actually it is not consuming any land. It is just a paper. You just do the imagination. By looking at this, you can imagine, okay, things are going to be like this during the execution, after the execution. Yes or no? Likewise, in Java, when you look at a class, by looking at this class, you are just imagining, okay, this class is just like a plan and is taking two inputs, and it is performing an output. It is giving an output in the form of what? In the form of number, which is also called as the addition of these two numbers. It is not like the output is displayed. Just a plan. Making sense? This is not going to, class is not going to consume any memory. No memory will be consumed by the class. Right? So, second thing, execution. The actual execution is like you're talking about the object creation in Java. Really, execution involves foundation, laying the foundation, hiring employees, constructors, plumbers, electricians, and they do a lot of work independently, and they take a lot of time. After conception, the house will be constructed and you are ready to occupy the house. A very big space. So this execution is actually consuming the space, consuming the land. So many things are involved. Likewise, object creation is going to consume the memory. When I say the object needs to be created for this, simply I will say that, okay, what I will say, test, name of the class, use the name of the class, give any name, variable name, object creation. This can be any name. You can give your name also, but the meaningful name is always recommended. New keyword, new keyword. Okay, new test. The syntax, class name followed by the variable name followed by the new keyword followed by the class name with what we call it as opening simple bracket and a closing simple bracket. When you do this, this is like execution. In the real world entity, for execution, this many steps are involved. Okay, but in Java, for execution, you need to do this and you need to call the method. Creating the object and calling the respective method on top of this object. For now, just try to understand this. This will we will discuss a lot about this. Now my agenda is we need to understand what is object oriented programming. Okay, you create objects for every class. That's why it's called as object oriented programming. So this statement is going to do so many things internally in the memory. Okay, because of this line, a memory space will be created inside the memory. Memory space will be created. Let us assume this is a memory. This memory is going to give space, create space for all the variables. This is variable 1. This is variable 2. A equal to 100, B equal to 200. Yes or no? Inside this object, A equal to 100, B equal to 200. Right? What is the name of this memory? Again, the name of this memory. Okay, object creation. This is the name of this memory. Object creation is going to be what? The name of this memory. Right? This is typically called as the execution phase in the house construction. So in Java, the object creation is nothing, is also called as the memory allocation. Memory will get allocated for all the variables. All the variables. It's not, we have only two variables. That's why for these two variables, the memory is getting created. Right? And we have a behavior, or we have a function here, or we have a method here. Okay, typically for this method also a memory gets created, but not in this area. That is a different part, that is in the heap area. Okay, for now just try to understand. A space is getting created, a land is getting created, or we call it as the space is getting created for the object, which means all the variables are going to get memory allocation with this variable name. This is one object, right? Can I have an advantage to create any number of objects. One plan, multiple objects. This is one object. For example, if the engineering is giving you the plan, okay, you can, if the plan is good, after the execution, if you see that the construction is perfectly fine, right, people will ask you, right, people will approach you, can I get this plan? What you do? Okay, take this plan. Okay, same things can be reproduced in different places, right? Plan is same, and after the execution, the houses are going to be same, right? One plan you can use for multiple executions. Plan is single plan, but this for executions we can produce multiple executions, right? Likewise, one class objects can be many, can be in thousands, it can be in 2000s. Making sense? Let's stop here. Okay, tomorrow it is going to be very interesting. Okay, I will keep it very slow. Okay, we'll complete this tomorrow, because tomorrow and again we have things to discuss, like what functional programming is there, logical programming is. I will ensure that tomorrow these two things are also completed. Okay, then we will start understanding about what we call it as how to design the program by using loops. Actual subject is coming. Any questions you have?